everyone. So during last class we have discussed about the how to calculate the mole fraction, and regarding that I have solved one question, but how many of you understood that concept I don't know. Still once more we will see that part, right? So during mole fraction calculation there are two main things will come into the consideration. So what are those? N of NaMol, that means number of moles, right? Number of moles. So before going for the calculation of a mole fraction, what we need to do is we have to calculate the number of moles. So number of moles, for number of mole calculation, I have given the same formula, that is weight of a compound. So weight of a compound divided by molecular weight, that means molecular weight of compound, right? So molecular weight of a compound. So that means here, so what we need to do is weight of compound they will give, right? So in yesterday's class, problem itself, they have given 40 gram of what, NaOH. If you are calculating for molecular weight, mole of NaOH means, so this becomes weight. They already give you, and the molecular weight. Molecular weight means already we know NaOH. For NaOH, what is the molecular weight? How many Na are present? 1 into Na. That means 23 plus oxygen is 1. So therefore oxygen molecular weight is 16 plus 1 into how many hydrogen? 1 hydrogen, 1 into 1. So thus 23 plus 16 plus 1 into 1. So 17, 7, 10, carry 1, 4, 3 plus 1, 4. So that means 40. 40 divided by 40, what we said in the yesterday's class, 1. Right? So in the same way, if we see the water molecule, so see, again we will take that same problem and I will do once again. So why? Because in yesterday's class, for me it looks a very fast class, so that's why I wanted to explain this mole fraction once again. Why? Because mole fraction is very important. So the mole fraction is nothing but what? The weight of a compound to the weight of a complete solution, right? So whatever the compound you take first the weight, they will give already, that means number of moles of a compound to the number of moles of a all compound present in a solution, one we can say, that is mole fraction. So if the problem is like this, means see the same thing, calculate the mole fraction of NaOH and water. We need to calculate mole fraction of both, mole fraction of NaOH as well as second one water, and they have given in the problem itself, they have given so 40 gram of NaOH, that means weight 40 gram of NaOH, the same problem, the yesterday's problem I am solving, and 180 gram of what, water molecule, right? They have given, this is our problem, we need to calculate the mole fraction. So mole fraction is nothing but, see, mole fraction, for mole fraction the formula is like this: mole fraction is equal to, say for example, if you are calculating the mole fraction of NaOH, or else simply we say mole fraction of any given compound, that means mole fraction will be represented by this letter H, and which is equal to number of moles of A and B consider, and number of moles of, if I say this as a A and this as a B, then total number of, that means Na plus Nb. See here, what is this? N is nothing but number of moles. So directly we cannot calculate the mole fraction, very important. So I am just writing the mole. After writing the mole fraction formula, what we come to know is we cannot directly calculate the mole fraction directly. So before going to mole fraction, this one we need to calculate, right? This is very important. After calculating the number of moles, then only we can go for the mole fraction. Understood? So see here. First we will take one, this is the problem, right? So now see here. If I go for the mole fraction of solution, first one, solution. So first, what we need to do before going for the calculation of mole fraction, mole fraction, number of moles. So moles, number of moles of first we will calculate NaOH. So number of moles of NaOH is equal to, right, weight of NaOH. Why? Because we are calculating for NaOH. Weight of NaOH divided by molecular weight of same, that is NaOH. This is our how to calculate the number of moles. That means for calculation of number of moles, we need to calculate its weight by its molecular weight. That is very important, right? So weight they have already given, that is how much, 40, and if you calculate this, just now I have calculated, so it will come nearly 40. So that means its number of mole of NaOH becomes how much? 1. Understood? So this is for NaOH, that is number of moles of NaOH. So now the same thing we need to do for water molecule also. Why? Because there are two components over here. So next, number of moles of water, H2O, which is equal to, again same, weight of H2O divided by molecular weight of H2O. So that means weight 180, right? In the problem itself they have given, and divided by, so molecular weight is, see here, 2 into H. H means 1 plus 1 into O. O means 16. 16 plus 2, 18. So that means 18 is our molecular weight of a water molecule. So thus 18 ones are 18 tens are. So therefore, for water molecule, our number of mole is now 10. If you calculate this, then the problem is very simple. So now see, just I will show. Yesterday also I have shown this. We have solved this problem. So now see here. Now directly go for mole fraction. Mole fraction of NaOH is equal to N into NaOH divided by N into NaOH plus N into H2O according to our formula. So NaOH is nothing but number of mole is how much? 1, and again 1 plus 10. So 0.09 nearly came. In the yesterday class only we have calculated. So mole fraction of, now just go for water molecule, that is H2O. So number of moles of H2O divided by number of moles of H2O plus number of moles of NaOH, which is equal to 10. Why? Because number of moles of water molecule is 10. So 10 plus 10 plus 1. So therefore it will be 0.9 like this. Right? So this is the mole fraction of what? Water molecule as well as NaOH. So I will give the same problem, right? So try to solve and send it to me, right? So number 2, calculate the mole fraction of, take it down, calculate the mole fraction of, calculate the mole fraction of NaCl and H2O, that is water, given, right? So 70 gram of NaCl and 18 gram of H2O. So this is the weight, right? So same you do right? As I did the last problem. So same, first you calculate the number of moles and then you go for the mole fraction. Very simple problem. One more if you want, you can take. Calculate the mole fraction of benzene, that means C6H6, and benzene and ethanol. Sorry, ethanol means I will give you the formula itself. Why? Because some of you might don't know the formula. C2H5OH given 172 gram of benzene and nearly 92 gram of ethanol. So you calculate these two and try to send me, right? So these are the two problems. So if you want, you can copy it also, right? So now the last part of this chapter. So mass percentage and volume percentage we need to calculate. So these are the two concepts left in this particular chapter. So these are also based on the calculation itself. So we will see very simple type of calculation. If you remember the formula, then one you can very easily calculate the things, right? Mass percentage. Mass percentage. So percentage means, remember dear student, percentage means one we have to go with the 100 or we need to multiply with the 100. Mass percentage can be calculated by using formula directly. When we can give using the relation mass percentage is equal to mass of solute, very important, divided by mass of solution, right? Mass of solution. We are calculating it in percentage. You multiply that with the 100, it will give. So what are percentage? So mass is nothing but when we can say we are calculating it in the solid form, right? So mass of solute. So here the trick is they will give two components. Among those two, they will give all the values of solute as well as solvent. But we need to identify which is solvent and which is solute. This is the trick of this type problems, right? So first we will see number one problem. So calculate the percentage of calculate the mass percentage of 20 gram of NaOH, 20 gram of NaOH present in 80 gram of water, present in 80 gram of water. So now see here, very interesting problem these are, right? So based on what the number of grams, one we can identify which is solute and which is solvent, right? So see here, 20 gram for what? NaOH they have given, and 80 gram for what? Water molecule. So now see here, 80 is more than 20. That means the solvent is one which is present in high concentration. So that means here 80 is more than what? 20. So 20 is less concentration, the component which is present in less concentration is called solute. So that means here NaOH becomes solute and and 80 gram of water becomes what here? Solvent. So this is the trick. And now what we need to have is for the solution, see here, here. So now see, first solution, see, So we have to say that which is solute and which is solvent. Mass of solute, mass of solute is equal to how much? 20 gram. So now mass of solvent, which is very simple to identify, which is present in more percent. You just give you mention that as a solvent, and which is present in less, which is a solvent. So solute. So solvent is 80 gram. So now you go for your calculation. So total now. So these two are forming what? Solution. That means what is the mass of solution? Mass of solution is equal to 20 plus, add these two, 20 plus 80, 100 gram. So the total mass of our this solution is 20 gram. Why? Because whenever the solute combines with the solvent, then only the formation of what? Solution takes place, right? So that's why what we need to do is we have to add up these two and now go for the mass percentage. So mass percentage is equal to, mass percentage is equal to, what is there in that? Mass of solute divided by, I will write once again, mass of solute divided by mass of solution. Mass of solution into what? 100. I will write this problem, right? So now very easy, very simple. So see here. So what is the mass of solute? 20 divided by mass of solution, how much? 80. Sorry, mass of solution is 100 gram into 100. So here definitely very simple calculation, right? 100 will cancel, which becomes 20%. That means mass percentage here is 20%. Right? Very simple this time. Volume percent and as well as this mass percent. We will go for one more class and then we will wind up this chapter. Thank you.